Welcome back to AI 101. I am Maya, and today we are addressing a paradox. In our last episode, we talked about the agentic loop and how the AI reads your code and runs your tests.
Hello, I am Theo. Here is the paradox. As we keep saying, the large language model is just a brain in a jar. It has no physical hands. It cannot directly touch your hard drive, it cannot open a terminal, and it definitely cannot press the enter key.
So when you ask the agent to run a shell command or edit a file, who is actually doing the typing? How does a system that only knows how to predict the next word manage to interact with the real world?
Today, we are exploring the hands. We're going to look at the mechanisms that give the AI agency, built-in tools, the model context protocol, and dynamic skills. Because understanding who actually runs the command changes how much you trust the system. Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself. Let us clear up the biggest misconception first. The model only ever emits text. It never executes a function, it never touches your disk, and it never makes a network request on your behalf.
Right. When it wants to take an action, it simply generates text shaped like a tool call. Usually this is structured JSON. It outputs a block of text that essentially says, hey, I would like to run this shell command.
It is the harness, the software running locally on your machine, that intercepts that JSON. The harness reads it, says, okay, the model wants to run a command, and then the harness actually executes it in your terminal.
The model is completely isolated. The harness acts as its proxy. It takes the text, turns it into a physical action, gathers the result, and feeds that result back to the model as more text.
This design is brilliant because it separates the intelligence from the execution environment. The brain stays purely analytical, and the harness handles the messy reality of file systems and operating systems.
To make this work, the model needs to know what actions it is allowed to ask for. The harness provides these capabilities in 3 different flavors. The first flavor is built-in tools.
Every modern coding agent comes with a core set of built-in tools. These are the fundamental actions a developer needs. They typically include tools to read files, search directories, edit code, and run shell commands.
When the harness starts up, it tells the model, here's a list of your built-in tools, and here is the exact JSON format you need to use if you want me to trigger one.
For 90% of your daily coding tasks, these built-in tools are all the model needs. It searches your project, reads the relevant files, and applies edits. It is a complete, self-contained loop.
But what happens when the agent needs to do something outside your local codebase? What if it needs to query a cloud database or look up an active incident in your tracking system?
That is where our second flavor comes in, MCP servers. MCP stands for Model Context Protocol. It is an open specification introduced by Anthropic in late 2024, and it is an absolute game changer.
Think of MCP as a standardized plug-and-play adapter. An external program, like a database client or an API wrapper, can run as an MCP server. The harness connects to it over a small, simple protocol.
The MCP server tells the harness, I offer a tool to query the production database. The harness passes that tool option to the model. Now, the model can emit JSON to query the database, just as easily as it edits a local file.
The third flavor of capability is what we call skills. While built-in tools and MCP servers give the agent raw actions, skills give the agent workflows.
A skill is essentially a packaged markdown playbook. When you invoke a skill, that playbook is injected into the agent's context on demand. It teaches the agent a specific, specialized workflow that it did not know 5 minutes ago.
For example, you might have a skill for generating a daily market video script. It tells the agent exactly which files to read, what tone to use, and where to save the output. It is a set of instructions combined with the tools to execute them.
It is incredibly dynamic. You do not have to fine-tune the model or write complex plugins. You just hand it a playbook, and suddenly it is an expert at a brand new procedure.
To show you how powerful these hands can be, let me share a true story from a real development session I had recently. It highlights what happens when tools meet the agentic loop.
Oh, I love this story. So, You asked the agent to run a specific script, right?
Yes. The agent generated the JSON to run the script. The harness executed it, but the terminal threw an error, command not found. A specific runtime dependency was missing on my machine.
Now, a traditional script would just crash and give up. But remember, the harness feeds that error back to the model.
Exactly. In the next lap, the model read the error, realized the runtime was missing, and generated a new tool call, a shell command to install the missing dependency. The harness installed it, the model retried the original script, and verified it successfully launched. It was a completely autonomous, self-correcting fix.
That story brings us to a perfect analogy. Working with an AI agent is exactly like being on a movie set. The model is the director, sitting in their chair, calling out actions.
And the tools, the MCP servers, and the harness are the stage crew. The director says, move the lights, but the director never actually touches a light stand. The crew does the heavy lifting.
And injecting a skill is like handing an actor a script for a scene they have never rehearsed before. They just read it, understand the blocking, and immediately perform it flawlessly.
The director only emits text, instructions, and commands. But because the crew is competent and connected to the real world, those text commands shape the physical reality of your machine.
To recap, the model itself has no hands and only emits text, usually in structured JSON.
The harness provides the hands through built-in tools for local files, MCP servers for external systems, and skills for specialized workflows.
It intercepts the text, performs the action, and completes the loop. But there is a catch. If all models use the same tools and the same loop, why do they feel so drastically different to use?
That is a great question. In our next episode, we will explore why the same agent feels different on different models and uncover the hidden math behind agent efficiency. See you then. And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.